Teledyne Brown Engineering has developed a groundbreaking experiment that's underway on the International Space Station. The ring sheared drop experiment will allow scientists to study the formation of potential destructive amyloid fibrils, or protein clusters, which have been found in the brain tissue of patients battling neurodegenerative diseases like Alzheimer's and Parkinson's. Normal brain function can be disrupted by amyloid fibrils, which refuse to dissolve the way most proteins do. Instead, they accumulate, possibly causing disorder to tissues and organs, which scientists believe may contribute to neurodegenerative diseases. Scientists can create these fibrils on Earth using shear flow, but researchers have found that container walls and heat convection negatively affect the experiment. In the microgravity environment, surface tension forces cause liquids to form self-contained spheres, eliminating the need for containers. These conditions are more like those found in the human body. During the experiment, 8 milliliters of protein solution, which is currently human insulin, will be injected between two contact rings. One is fixed, and the other will spin to create shear flow forces. Scientists believe that this will create the fibrils needed for their study. Teledyne Brown Engineering has also designed electronics and software for the experiment to be controlled from Earth at their facility in Huntsville, Alabama. Principal investigators at Rensselaer Polytechnic Institute in Troy, New York, were partners in the experiment and hope to later adapt the ring shear drop facility as a space-based bioreactor for other studies. The experiment was launched to the International Space Station in July 2019 aboard SpaceX 18 as a part of the Commercial Resupply Services program. It will be operated in the Microgravity Science Glovebox and is expected to last at least 2 years. We are afforded this exciting capability thanks to the International Space Station and its microgravity environment. In just a few short years, we hope to be closer to unlocking the mysteries of these diseases that affect so many people across the globe.